Hello everyone, welcome to part 2 of Decoding Strategies in Text Generation. So let's briefly recap what we saw in part 1. So we looked at greedy search, beam search, and some sampling strategies like random top K, top P, and we also saw impact of temperature in sampling. So here by search we mean like we have some tokens and the model is giving you probabilities of different tokens in the vocabulary of occurring next. So how do we pick the next token? That is search here. So let's see the code demo in this lesson for all of these. So first let's start by importing the tokenizer and model. So in this exercise we will be using GPT-2 model. So this is auto model for causal LM. So some models which are trained using auto-regressive fashion where the goal of the model is to predict the next token given a few tokens are called causal LM models or auto-regressive models. So let's wait for a few seconds. So this is the first time the runtime is also initializing. So let it initialize. So now the model and tokenizer has loaded. So first let's give it a token or a sequence of tokens. It was a fine sunny, and the goal of this GPT-2 model is to predict the next tokens. So this is tokenization. So this tokenizer will break this text into tokens, and each token will have some ID. So you can print these and look at these. These will be some numeric IDs from the vocabulary. So first of all, we will just for the sake of understanding, we will see what is the output of model. So this calling this model is nothing but this GPT-2 which we loaded here. So it will run a forward pass through all the input IDs generated by tokenizers. So we call these raw outputs as logits. So if you see the shape, it's 1550257. So 1 is the batch size. We have given it just one sequence of words. So that's why 1. 5 means how many tokens it was broken into. So it's 5 tokens. And then this 50,000 denotes the size of vocabulary. And if you see, each value will correspond to some probability value between 0 and 1. So there are 5 times 50,000 probability values. So each of these 5 corresponds to one of the tokens. So this model function, so it ran forward pass after giving the model just first token, which most likely is it. So for it gives you 50,000 probabilities, one corresponding to each token in the vocabulary, saying that what is the probability of this token occurring after it. So and similarly for the next token, it again gives probability of all the tokens in the vocabulary, like how likely it is to occur after was, then a, and fine, and sunny. So that's why this is the shape. So let's say so this 0 means first batch size. In this case it's 1 only, so this 0 is not doing anything here. So here we have 5 tokens. So we are, let's say, interested in what occurs after these 5 tokens. So numbering starts from 0. So 0, 1, 2, 3, 4. So this is the 5th token, that is sunny. So we are checking what is the maximum probability among these 50,000 probabilities corresponding to this word or token that occurs after sunny. So let's print that. So the most probable word is day. So the model says that it was a fine sunny day. Day is the most likely word. So let's try after fine what it says. So again, if you give it was a fine, the model thinks that next word should be day. It was a fine day. Similarly, you can check for other, like let's say 2. So it says that it was a. If you give it was a, it will say very, the most likely word. It was a very. You can check others also. So if you give it, just it, then it will say it was, then it will say A, and actually it was A. So it just looks at previous words. So if you give 0, then that means you are just giving the model it. So if you give it it, it says is. Is the most likely word to occur after it. So you got the idea. We have the raw logics, but we generally don't work with this. So you have to do a bulk of loading, handling of these logics yourself. But just for your information, I wanted to show it that you have this raw output probabilities for each token in the vocabulary with you. So if you want to do something custom, you can write your logic in this fashion. Now let's get back to our topics like greedy search. So if we have this 5 tokens here, how do we pick the next token? So we see that we have 50,000 probabilities. So how do we pick the next? So greedy is like similar to what we did here manually. So it says that pick the most probable word. So from the dictionary, all the probabilities, check which is maximum and just append that word. So now it will append. So if you saw what was the most likely word after 4, it was day. So now just append day here. So it was a fine sunny day. Again run forward pass through the model and again pick the most likely word and again append the output to the sequence and again run it through the model and continue in this fashion. And we are giving a maximum length of 50. So once 50 tokens are reached, it will stop. So this is the approach of greedy search. So we can see that here we were using model function which ran plain forward pass through it. Here we have a generate function that implements some of the logic that we did here manually. So what generate does is that it calls this model or the forward pass. It gets the next, picks the next token from the probabilities based on the strategy that we give, in this case greedy search, appends that token back to the initial sequence, again runs the forward pass and again does the same thing until max length is exceeded. So let's see what is the output with greedy search. So it says it was a fine sunny day. So after fine sunny, it picked the next probable word as day and then comma and I and so on. So this is the output. It was fine sunny day and I was sitting in the back seat of my car and I was thinking I am going to be in the car for a while and I am going to be in the car for a while. So you see that the problem we talked about in the lesson is coming here. It started to repeat itself. I am going to be in the car for a while and I am going to be in the car for a while, because we are picking always the most probable word. So after going, the most probable word is 2, same here, and then B. So let's try with 100 what it says. I am going to be in the car for a while, I am going to be in the car for a while, I am going to be in the car for a while. So just to emphasize, you can see that it's repeating, it's stuck in a loop because it's always picking the most probable words. So that's why this greedy search may not always be the best strategy. So beam search is pretty much similar, but instead of just keeping one sequence, it keeps track of number of beams, which is 5 in this case, searches, and keeps on multiplying all the paths as we saw in the lesson. So greedy search missed the most probable path, but beam search was able to do that. But still here also you can face the same repetition problem. You can see it was a good day multiple times. Good day for me, he said. And now let's look at sampling. So that's why we use sampling techniques, so that instead of just picking one token, we have a probability of picking different tokens randomly. So that's random sampling. And then top k sampling, we have top k is 50. So pretty much random. We can keep it to 5. Top 5 most probable words. And the probability of picking them is also in there. Same ratio. So So it was a fine sunny day and I was sitting down at home watching my wife, blah blah. So you see, you don't see that kind of repetition here as we saw in the greedy approach. And top P is similar to top K. Here we are specifying that pick the top K probable tokens. But instead here we give it a probability value. So 0.9 means pick the most probable token. If it's already 0.9 or more, then just pick one. But if let's say the most probable word had a probability of 0.3, then it's less than 9. So pick the next probable, 0.2 maybe, and so on until the cumulative probability of those tokens that you picked. Maybe you picked 10 tokens and now it has exceeded 0.9. So you stop. So again, you will not see repetition kind of problem here, and the generation should be much more random. Then we had seen that we have a role for temperature in the sampling as well. So the more your temperature is increased, the more randomness is induced. So if temperature is 0, it's similar to the greedy one. So let's first try with a 0 temperature also, like temperature is 0, and let's see what is the output. Positive float. So again you see I am going to in the car for a while, I am going to in the car for a while. So temperature is close to 0, that means kind of 0 randomness, and it's equivalent to greedy approach. Then we have a reasonable value of temperature, that is 0.7, and the generation would also be reasonable and not very random. But if you have a high value, let's induce even more, 5.5, and let's see what it generates. It will be super random, it may lose context. It was a fine sunny day during World First Day weekend, which turned perhaps coincidentally for me on 4th November. So you see that it's losing the coherency, or it's doesn't look like a well-formed sentences because it's very random. So you can change the temperature parameter also to control your generations. So in the next lesson, we will look at transformer architectures.